Okay, the circuit diagram is looking on screen, the same thing, and also procedure, gain, and different types of gain based on the your frequency. You are able to identify that. Now we need to go for the second order high pass Butterworth filter. Circuit diagram, I am going to write it on the board, and you will come to know what is the equation for that. Okay. First, once you know the first order high pass filter, it is easy for you to find out the second order high pass filter itself. Let us go for the second order high pass filter. How exactly it looks into? We know the first order, write the first order circuit diagram. This is the first one. We will be having one capacitor, two capacitors, and one resistor which is grounded. The second one, resistor, which is connected to output. We have the input like V, C1, C2, R1, R2. If you want, you can change. Okay, I'll make this one to R3. See here, they are given 33 kilo ohm, 33 kilo ohm. Capacity is given as 0.0047 microfarad. R1 is 27 kilo ohm. R is 20 kilo ohm. 15.8. RL bigger 10 kilo ohm. topic is repeated. So many times I repeated this one. Online also I have done this on one day. It's been everyone has done it. So the same thing, but in the explanation, the equations are not being given. Just a circuit diagram I given. How exactly it's going to be built? How exactly it's going to be connected? Where exactly the capacitor resistors are supposed to be? That's what I have done. But these equations are very much important. Where you need to do numericals. There will be numericals definitely with theory. There will be numerical also. They may be asking for 8 marks or 6 marks theory, 4 marks numericals. Okay, they may be asking for 4 marks theory and 6 marks numericals. They will be asking. You should know, once you know the theory, once you know the equation, you can answer numericals also. So here, say, high pass filter during the low frequency, it's a stop band. It will not permit any frequency to reach the amplifier. All the frequency will be filtered out. Okay. Only high frequency component only is going to be given to the op-amp itself. Since there are two sets of filters, instead of 20 dB, we go for the 40 dB. Okay, 40 dB we are going to get that pressure. We are not going to get the 20 dB, we get the 40 dB cutoff, we are going to get that one. So stop initial will be at a stop band frequency, and later once it reaches cutoff frequency, it goes for the pass band. The equation which is given as V naught by gain, there is a magnitude. Here the magnitude has been given, which is given as the gain divided by the actual frequency component what we are going to have. Frequency is represented or defined or determined with respect to R1, R2, C2 and R3, C3. Okay. So FL is R2, R3, R2, R3 and C2, C3. That's why I written R2, R3 only I written over there, because R1 we are using the inverting terminal. I'm not using the R1 here. Okay. R1 will be generally it will be giving the gain. R2, R3 will be giving your frequency. Okay. Don't get confused with R1 there also, R1 at the bottom also. So inverting terminal is connected with the R1 and RF. Non-inverting terminal is connected with the two resistors and two capacitors. They are represented by C2 and C3. Okay. So in the low pass filter, we are using R1, R2, C1, C2. But in here, we are using R2, R3, we are using over there. So better have some common terms, so it will be easy for you to determine that price. Okay. So this is the high pass second order Butterworth filter. Okay. So we will be having 40 dB cutoff. We are going to have that one. 40 dB cutoff instead of 20 dB cutoff. That is what your high pass second order high pass filter completed. Then we have to move on to the band pass filter. Band pass filter also I have explained that one. Block diagram I explained it over there. What do you mean by band pass filter? I don't want low frequency also. I don't want high frequency also. Only in between frequency need to be transmitted. In between frequency. Any clarifications here? Any clarification with respect to second order high pass filter? I am going to put in band pass filter. Very simple. Band pass filter. Just write the waveform, then it will be easy for you to analyze that one. Assume that one circuit I am going to design such a way that it should pass some frequency. It should pass some frequency. Then what I am going to do, output of this one, I will give it to some other circuit. Output of this one, I will give it to some other circuit. This output. Okay. So in that one, what it will do, it will go like this. Initially, I am having the frequency. Frequency has been given to one circuit. Okay. It is assume that is a low pass filter. So it will pass the low frequency. Once it reaches the high frequency, it will stop that one. Okay. And output of that particular filter has been given to the input of the other filter. What that filter is high pass filter. Okay. So in that one, what are the low frequency component is there, that will reject. And once it reaches this lower cutoff frequency, From there it will start, then it will stop. This is one way. Other way is, first we have an actual signal. Some actual signal, input signal is there. Pass it to the high frequency component, pass it to the high frequency filter. So what it will do? It will stop the low frequency component, and once it reaches the FH, from there it's going to pass that one. Then this output, you give it to the one more circuit. Output of this circuit, you give it to the one more circuit. What it will do? This will be given. It will go like this, take like this, and go for up to some level. Then one more cutoff frequency has been given. One more cutoff frequency. In that cutoff frequency, it will go. Okay. So both the way is possible. You can give the initial input to the low frequency filter, low pass filter. Then output of the low pass filter, you give it to the high pass filter. That will convert. Otherwise, initially use the high pass filter first. Get the high pass frequency like this. Then this high pass frequency you give it to some other filter which is a low pass filter. Okay, so you go, and once it reaches the low frequency FH, that is FH. This is FL. This is FH. Okay, so this is what we have done. FL. Okay, here is the FL. Low cutoff frequency. Okay, once the low cutoff frequency comes, this is the low cutoff. Go for it. Then this output you give it to the your one more frequency, that is filter, that is low pass filter. That is FH you define there, and that FH will stop the frequency voltage. Now I should pick up the circuit such a way that first I will write the first order high pass filter. Output of the first order high pass filter, I will give it the first order low pass filter. Then that will give me the output voltage. Let us see how it looks. First, they have used the high pass filter. Output of the high pass filter has been given to the low pass filter. High pass filter. Okay, input signal has been given to the high pass filter. First one is the high pass filter, and it's been amplified. That amplified output has been given to the low pass filter. Okay, very easy. Let us see how exactly it looks. The circuit. High pass filter here. Here is the high pass filter. This is the amplifier. Okay, which has been amplified. Then the output of that one has been given to the low pass filter over there. Here the capacitor is in series, resistors in parallel, and output of this amplifier has been given to resistor in series, capacitor in parallel. So it will stop the high frequency. It's going to allow the some set of frequency over there. Simple circuit, you can go for it. This is what I told you. High frequency, then that high frequency is going to be given to this one. Then you are going to get the actual frequency. Active band pass. We'll be having, this is stop band, right side also stop band. In between frequency, we'll call that the band. Okay, band, that is pass band, and that is 20 dB. 20 dB signal only we'll call that one. 3 dB signal, 20 dB signal will go for. This is not required inverting. Okay. Multiple feedback band pass filter, that is also not required. So this is extra. So this one more thing, band rejection is also there. Band rejection is there. Band rejection, what it is? I'll give input signal, same input signal for the low pass filter also, same input signal for the high pass filter also. Low pass filter is the low pass output, high pass filter will be the high pass output. Then I'm going to sum them. I'm going to get the summation of both of them. Low pass plus high pass. In between, whatever is cut off will retain as it is. Okay. band rejection. We have a low pass filter, we have a high pass filter, and add both of them comes like this, goes like this. This is one filter which is giving the low pass filter output. There is one more separate filter which is giving the high pass filter. Okay, this is your FH, this is your FL. Okay, so both of them, both the circuits, both are separate circuits. Output of both of them has to be given to the one more op-amp signal. Where both of them are sum. So this will be as it is going to be written, and this will be as it is going to be written. In between, what we are going to have is a stop. This low pass filter, high pass filter, in between stop. Okay. So that is. So this particular fourth module theoretically has been completed. All gain is either AF less than AF or 0.707 AF. That's all. Not more than that. Only 3 signals will be there. Let's have a break. Third hour class is there. I should only take today, entire day. No Swapna ma'am, no Darshan sir. Only Prakash sir is available.